All right, let's jump right into today's explainer. We're taking a deep dive into the harsh reality of cyber attacks by decoding source material that ranks the top 10 hacker commands. Look, if you want to understand how systems are actually compromised in the real world, you are definitely in the right place. Let's pull back the curtain and see what a hacker's true arsenal looks like. When you picture a hacker, what comes to mind? Hollywood has totally trained us to imagine some shadowy figure frantically typing mysterious magic code into a glowing terminal, right? Well, our source material completely dispels that myth. It turns out they don't actually need mystical custom-built scripts to bring a network to its knees. And that brilliantly brings us to the core thesis of our explainer today. Quote, "The truly terrifying thing is just a few Linux commands." You see, the absolute most dangerous weapons in a hacker's toolkit, they aren't exotic malware strains brought in from the outside. No, they are the everyday, built-in Linux commands that are literally already installed on the very system you're trying to defend. Okay, kicking off our countdown at number 10, this brings us into phase 1 of a hack, disoriented reconnaissance. When an attacker first breaches a system, they're essentially blind. So what's the very first thing they type? Who am I? It's honestly one of the simplest commands in all of Linux, but it carries immense weight. The hacker is basically asking, who am I right now? If the terminal spits back the word root, well, the reconnaissance phase is pretty much over. They know instantly that they hold the keys to the kingdom. Moving right along to number 9. Now, if they aren't root, the momentum shifts to figuring out the specific identity of the system they just infiltrated. They use uname-a. To a regular sysadmin, this is just a boring quick way to check system info, but to a hacker, this is a treasure map. It reveals the OS type, the CPU architecture, the hostname, and absolutely most critically, the exact kernel version. Why does that matter? Because if they spot an outdated kernel, they can instantly cross-reference it against databases of known vulnerabilities. Boom, they can deploy devastating known exploits, things like Dirty Cow, OverlayFS, or Dirty Pipe, to force their way into administrative privileges. Down to number 8 on our countdown. This is the final step of initial recon. They know who they are, they know the OS, but now they need to figure out what kind of digital room they're locked inside. They use iPay, which is part of the iRoute 2 suite. This is basically the modern replacement for the old ifconfig command. By checking out the network interfaces, IP addresses, and MAC addresses, the attacker maps out their immediate environment. Like, are they looking at a basic virtual network interface card? Are there Docker interfaces? Or maybe a Kubernetes VEth pair? This one single command tells the hacker if they are trapped in a simple virtual machine, a Docker container, a Kubernetes pod, or some massive sprawling cloud instance. Hitting number 7, we're shifting gears into phase 2, scanning and sniffing. The hacker has their bearings, so now they start looking for doors to other systems. I like to call this the Jekyll and Hyde flip. Take netstat tunein-elp, or its modern equivalent, SS tunein-elp. The normal admin uses this to make sure legitimate web services are running properly, but the hacker's view, they use it as a door checker. They're scanning for poorly configured exposed ports. If they find 0.0.0.022, that means SSH is exposed to the entire world. Finding 0.0.0.3306, that means a MySQL database is just sitting there, completely vulnerable, just begging for a brute force attack. All right, number 6. Instead of looking at network doors, the attacker now needs to see what the machine is actively doing behind the scenes. Enter PSAUX. A system administrator uses this to monitor web servers and make sure their endpoint detection and response agents are running. But the hacker, they use it to find those exact security agents so they can actively dodge them. And here's the really wild part. This is also where hackers hide their tracks. Malware almost never calls itself something obvious like evil virus. Nope, it hides right in plain sight under fake legitimate-sounding process names like Kworker or systemd helper. To the untrained eye, it literally just looks like standard Linux background noise while it quietly steals your data. We are halfway through. Coming in at number 5, the stakes start getting a lot higher. The hacker is moving from just looking around to actively eavesdropping. This is where TCP dump comes out to play. Think of it as the ultimate packet eavesdropper. Despite all our modern security tech, so many internal company networks still route traffic using unencrypted HTTP. It's crazy. If internal systems are chatting in plain text, TCP dump will literally catch unencrypted usernames and passwords flying across the network in real time. Moving to number 4. If TCP dump is quietly listening at the keyhole, this next command is like kicking in the front doors of every single building on the block. I'm talking about Nmap, specifically scanning a subnet like 192.168.1.0/24. This is the ultimate network scanner. With one single sweep, it exposes a company's entire internal architecture. Live hosts, open ports, exact operating system types, web server versions, detailed service fingerprints, it finds it all. It can even run automated vulnerability checks using the Nmap scripting engine. Yeah, it is incredibly loud, but if a company's internal monitoring is weak, it hands the hacker a complete, highly detailed blueprint of the entire network. Top 3, we are now entering Phase 3, execution and lateral movement. Recon is over, it's time to reach for the primary weapons. Number 3 is curl. Most normal users think of this as just a simple command line tool for downloading files. But to a hacker, it is the absolute Swiss Army knife of exploitation. They use curl to interact with APIs, to test for server-side request forgery, which is basically tricking the server into making unauthorized requests, and to upload malicious payloads. And if they happen to be in a cloud environment, curl is absolutely lethal. By querying the cloud metadata IP, 169.254.169.254, they can literally trick the server into handing over highly sensitive cloud access tokens. At number 2, the tension peaks. The hacker has credentials, they have payloads, and now they need the command that lets them spread across the network like a spider web. That command is SSH user at target. Now, SSH is obviously a total necessity for administrators. It's the standard remote control tool for Linux. But for a hacker, it's the engine of lateral movement. If they manage to steal a poorly secured SSH key or maybe capture a password earlier using TCP dump, they can use SSH and advanced tricks like agent forwarding to jump unhindered from machine to machine. This is exactly why a leaked SSH key is a literal code red emergency for any organization. Okay, drumroll please. We've reached the climax of our countdown. Number 1, the ultimate prize. The most terrifying command of all doesn't require any complex 0 days or sophisticated malware. It relies entirely on basic human error. The command is sudo su, and the crucial failure point is the configuration no pass wd all. You see, in a lot of companies, admins will misconfigure the sudo file just for convenience, letting engineers execute administrative commands without typing a password every time. When a hacker compromises a basic, low-level account that happens to have this misconfiguration, they literally just type sudo su, hit enter, and instantly achieve root privilege escalation. Game over. Before we wrap up, our source material also highlights a few quick bonus commands worth keeping on your radar. History, to see exactly what admins have been typing, find in grep, to hunt for hidden passwords, and wget for pulling down malware. But really, all of this points back to the core lesson of today's explainer. Hacking isn't about magic. It is simply a deep, fundamental understanding of Linux processes, kernels, networks, file systems, and permissions. Which leaves us with one final, massively vital question to ponder. Linux can protect the world, or it can destroy it. Do you truly understand the system you are defending? Let that sink in for a second. You have to master the basics because I promise you the attackers already have. Thank you so much for joining me for this explainer. If you found this breakdown helpful, you are absolutely going to want to tune into our next one, where we'll be exploring exactly how hackers use eBPF to hide right inside the Linux kernel. It's going to be wild. Until then, stay curious and stay secure.